Hello there. Today's presentation will be on classification systems, which provide the foundation for library organization and, as we'll see throughout this presentation, so much more. To introduce my group, we're Group 4, and I'm Nancy Roque. My other group members are Alexandra DeLuna, Angela Hood, Angela Riccio, and Brendan Driscoll. First, I wanted to define classification systems to provide a better understanding of what they are and how they came about in order to create a better context for the rest of our presentation. Classification systems, on the most basic level, are a method of organization for libraries that were created in order to help service patrons and maintain physical housing. This came about as a result of the sheer amount of literature and other media that exists in the world today, and this amount is only growing as time goes on. In order to ensure that patrons and librarians alike are able to find the items they seek, rather than searching through thousands of stacks with an idea of where to look specifically, classification systems were put into place. To offer a concrete definition, Chan, in her 2007 book titled Cataloging Classification and Introduction, states, library classification in particular has been defined as the systematic arrangement by subject of books and other material on shelves or of catalog and index entries in the manner that is most useful to those who read or who seek a definite piece of information. Later, Chan further clarifies her definition of the services classification systems aid in by stating that classification as a term refers both to the development of schemes for systematic display of all aspects of the various fields of knowledge and to the art of arranging books or other objects in conformity with such schemes. The need to categorize is part of the human psychology that is used to organize our lives and the world around us. This habit of ours has, understandably, made its way to the library system, where order is not only helpful but necessary. According to Lazarenis, in his 2015 book titled Cataloging Classification, classification systems date back to ancient Greek libraries and Aristotle's classical philosophy theory of categories. Additionally, the poet Callimachus created a catalog for the Library of Alexandria, which arranged entries into at least 10 main classes. Over time, classification systems diversified in order to answer to the different needs of the various types of libraries. For example, the Dewey Decimal System was created in 1876 and involves information divided into 10 main classes, then subdivided decimally to form a total of 1,000 categories that are numbered 000 through 999, and an alphabetical subject index as well. The Library of Congress classification system, on the other hand, was created in 1897, and it consists of 21 classes displayed in over 40 separately published print schedules and a large database. The Library of Congress classification system is continually updated as time goes on in order to supply new information and new levels of organization. To state simply that classification systems are only used to organize books would be an understatement. These systems allow for physical housing of the books, letting staff know where certain books should be replaced, and where a new book should be shelved into the system after a librarian or staff member reviews its topic and sees what categories and specific area the book would fall into when using their specific classification system. The use of classification systems also save both the patron and librarian time in the future when looking for a specific item, which is a necessity when a library is busy and one cannot dedicate hours of browsing to find a single item, which, to be honest, not many people can say they have. Additionally, classification systems also help maintain a traceable catalog within each library. Since these classification systems can be translated into computer programs, information can be found digitally about where an item is, or at least should be, located. And, as we're about to see, the reasons why classification systems are a necessity at every library continue. Classification systems demonstrate available stock, as I mentioned earlier. To be more precise, the information that becomes available through the use of classification systems and the level of organization they provide transforms into data that can be used by librarians to maintain their stock, Additionally, patrons and librarians can also find out where a book is located and whether or not it is already checked out through different websites and programs that they can access at home. Using the information that can be found online through the use of classification systems, patrons are also able to check out books. Although this is not a direct function of classification systems, it definitely complements the use of this kind of service within every library. Additionally, libraries could also use the system to ascertain what fields, materials, or areas of information the library should look into stocking more of, as a classification system helps run the catalog that a library uses to get this sort of data that will then be used to buy new material, weed through old unused material, and so on. As you can see, all of these reasons are already building a case for why classification systems are a necessity in libraries, since they not only provide organization at a very basic level that can be implemented throughout the whole library, but also the information that comes from classification systems in general and the information that comes out of whoever is organizing the materials to be classified can also be used in a multitude of extra ways that maybe weren't so easy to distinguish at first. As you can see, all of these reasons are already building a case of why classification systems are a necessity throughout all library branches and locations, since they not only provide organization at a very basic level, but they also come into play on different functions of the library that one may not have been able to easily distinguish at first without going through classification systems on a very detailed level. But before we move on, I also wanted to note that classification systems are necessary because they provide a set of structure that can be put into place across all libraries, despite different libraries focusing on different areas, such as public libraries and academic libraries. The systems that they use can be recognized and easily put into place without each library having to create an individual system for themselves. Instead, for example, a lot of academic libraries that are found at universities and different schools tend to use the Library of Congress classification system simply because it suits their needs best. Classification systems also function on a level that is higher than simple organization. These systems allow items to be located quickly, saving staff and patrons a lot of stress and energy. This makes visiting the library an efficient and easy process that people are more likely to repeat, rather than a stressful experience that takes a lot of time, which would happen if classification systems were not in place. Additionally, classification systems allow items to be co-located, meaning a user can spend a bit more time in an aisle gathering in for additional material because books of similar subjects are stored in areas that are of close proximity to each other, which becomes clear if you've ever gone to a library and found a book that you like on a specific subject, such as farming, because other books on farming will be located right next to or directly above or below the book that you found. And this is all thanks to classification systems that your library has put into place, which stores materials in a logical manner. As an added bonus, classification systems are also able to connect libraries by giving them an overarching system to work within, making functions such as interlibrary loans more feasible by letting libraries see whether or not something's in stock, where it's located, or, on the other hand, seeing which library the item is located at. So, it's clear to see, without classification systems, this whole function would be a lot more difficult, if not impossible, without the organization and structure provided by the system put into place by specific libraries. And finally, it's important to note the final function of classification systems that I'll review, which tags along with the advent of the internet and the digital age, which allows librarians to use their classification systems to complement the search of information via the internet, allowing for websites and programs like WorldCat to work so well, because they allow patrons and librarians to search for information through the comfort of their own home before coming into the libraries to find the physical version of that information. Without the classification system, that level of organization and detailed tracking would not be possible. And that will conclude my segment of this presentation. Thank you so much for listening.
Let's discuss the two main classifications most commonly used, the Dewey Decimal System and the Library of Congress classification. There are two main systems of classification used widely by libraries. These are the Dewey Decimal System and the Library of Congress classification system. The Dewey Decimal System has been adopted as an organizational tool by academic, public school, and special libraries in the U.S. and is also used by over 20,000 libraries around the globe. It was first published in 1876. Now, on its 22nd edition, it has been translated into over 30 languages and has become the most widely used classification system throughout the world. The Dewey Decimal System was created by Melvin Dewey during his time employed as a library assistant at Amherst College. He created it after studying numerous books and pamphlets, as well as making personal visits to different libraries in the United States. Dewey based his new system on these studies, as well as the earlier devised system of W.T. Harris, whose own work was based on Francis Bacon's classification of knowledge. System was Dewey's newly created DDC, however, when compared side by side with the work of the other two scholars, presents his more modern approach on organizing information. At Table 13-1, in Chapter 13 of our textbook, we can see Bacon's original divisions of knowledge into three categories: history, or memory, poesy, representing human imagination, and philosophy, or rather reason. As the chart shows, these were later inverted and expanded upon by first Harris and then Dewey, who again revised them. In addition to his new classification scheme, Dewey also added the features relative location, which grouped books in terms of their relationship to one another, as well as relative index, which groups information together under one term in the scheme of a subject, which may often fall under different fields of study. The Dewey Decimal Classification System consists of 10 main classes that are divided decimally and form a total of 1,000 categories that are numbered from 000 to 999, and also includes an alphabetical index. Each of the 10 main classes are then subdivided into 10 divisions, and then divided into 10 sections, further subdivision being made from there as needed. Here we see the 10 main classes divided in the DDC, which still mirror the recognized academic divisions of Dewey's time. Those were general works, philosophy, theology, sociology, later became social sciences, philology, the study of written languages, natural science, useful arts, fine arts, literature, and history. The second and third divisions are much more detailed and can be found under Dewey Services on the OCLC website, which is listed at the top of the slide. Briefly, the second summary contains divisions, which are denoted in the second number of the 3-digit DDC entry. The third summary contains the thousands divisions, which are represented in the third number of the entry. A decimal point follows the third digit in a class number, after which division by 10 continues to the specific degree of classification needed. Now, let's take a look at how the DDC's notational hierarchy is structured. We start with our main classes, in this case 600, which classifies technology. Next, we see that if we are to divide to the hundredths division, we come to aggregate agriculture and related technologies. We further divide and come to animal husbandry under 636 by a decimal subdivision to classify under dogs and cats specifically, 636.7 and 636.8.
The second of the main systems of classification is the Library of Congress classification system. The Library of Congress moved to a new building in 1897. At that time, it was determined that the old Jeffersonian system was no longer adequate to be used to classify the library's ever-growing collection of information. The LCC was developed to replace the old system and was a collaborative process that enlisted the help of many different specialized groups of individuals who helped to create the new system's categories and subcategories. The task of developing the LCC was directed by J.C.M. Hansen and Charles Martel. The two were primarily responsible for its design, for which they chose Cutter's Expansive Guide as their chief guide. The Library of Congress classification system was organized by divisions of class, subclass, or subject, originally appearing in a general pattern referred to as Martel's 7 points. They are 1. General form divisions, 2. Theory, philosophy, 3. History, 4. Treatises or general works, 5. Law, regulation, state relations, 6. Study and teaching, 7. Special subjects and subdivision of special subjects. This pattern has been altered somewhat by the addition of new information and changes to the LCC structure through time, but it is generally still discernible today. Now we will discuss the overall structure and division of the LCC system. The LCC is divided into 21 main classes that are classified under single capital letters. The main classes are then further divided into subclasses, also under single capital letters. The subclasses are then further divided into components of the subclass, with Arabic integers from 1 to 9,999, and then further divided with decimal extensions or Cutter numbers that are a combination of a capital letter and one or more numerals. Our next slide shows us an example of the three main divisions of an LCC classification. First, the main class is assigned Q to science. Next, it is designated with the letter D, making its denotation QD, which represents chemistry, more specifically as the branch of science. Finally, our subject is assigned with the numeric classification 146 through 197, designating inorganic chemistry. The process continues depending upon the specificity of our subject classification.
A general classification principle followed by Library of Congress classification, otherwise known as LC or LCC, and Dewey Decimal Classification alike is each classification system's focus on identifying an item by progressing from the general to the specific. This narrowing down methodology gives LCC and DDC editors the ability to make additions and modifications to both systems, as well as an opportunity for further precision in the classification process. However, these similarities between the two are subject to the era in which they were created. Both were created in the 19th century, during a time in which libraries were moving from the most likely an extension to a private collection to the public. Even though that transition had been happening for centuries, this was when the real money started going into public libraries, or really increased dramatically. And they were And both of these were designed with the need for uniform classification systems, which allows libraries with exceedingly large collections to give each item a unique identification code. Aside from their utility, these two classification systems are fundamentally and philosophically divergent from one another. Melville Dewey primarily developed DDC, and LCC was developed by a team of subject specialists with the intention of redesigning the currently standing and outdated classification system in place at the Library of Congress. The team of subject specialists that developed LCC had a much more local and varying approach than Dewey, due in part to the origins of LCC. The LCC system is best suited for tracking items of individual collections rather than Dewey's overarching uniform code, and by that I mean that it's relevant to items that are already published, not necessarily trying to catalog everything in existence. Unlike DDC, LCC uses mixed notation, which allows for added variety and newer combinations for LCC identification codes. Instead of being limited to 10 digits or 10 major classes, LCC can be expanded, is divided by 21 main classes, and a seemingly infinite number of numerical combinations. However, both of them can add digits after the main subject code in the form of tablets and cutters, which will be discussed later or compared later. DDC and LCC both have empty numbers and letters respectively to allow for future expansion and modification if need be, which they do. In light of the philosophical structure of DDC and LCC, the two systems take classification methodology in entirely different manners. Dewey's goal in creating DDC was a reactionary response to contemporary identification schema at the time. In other words, he based his model heavily off of W.T. Harris's classification system. The strength of DDC is incidental to the number of editors constantly updating Dewey numbers online and while they publish the Red Book, which is published every 8 years. DDC takes the more proactive route and attempts to classify the entire body of knowledge in anticipation for future publications covering a subject. However, the classification schema produced is limited to the Dewey Decimal Classification System's editor's ontological variety and epistemological acumen. In other words, the information specialists have to take their geological and cultural background into account when creating new subclasses or modifying old information in DDC. For example, when Dewey created his classification system, he dedicated a large number of subclasses to Christian-based religious texts, and seemingly lumped every other non-Western religion into a set of broadly defined subclasses. This is an extreme example, and editors have striven to rectify these shortcomings over the past century, but the issue still persists in some areas. Dewey has a history of ill-representing Eastern and ancient cultures. With such a large undertaking to classify all known knowledge, some subjects can be left behind if there is another, more prevalent issue facing DDC editors. Instead of working towards classifying potential and extant item subjects, LCC focuses on items and subjects that are readily available and published, so essentially books and items that are already inside the library, for the most part. The intellectually gifted may have already guessed this, but the Library of Congress staff designed LCC with the Library of Congress in mind. That is, this classification system was designed to accommodate the needs of an individual library. This doesn't mean librarians in 1897, the year that it was released, were creating their system without any anticipation to other libraries using it, but similar to Dewey, information specialists can, Similar to Dewey, information specialists that can read LC call numbers can witness the cognitive footprint of the classification system's developers. For example, in the 21 main classes, there are 2 main sections about American history in LCC. Letters E and F cover American history and the history of the United States and its interactions with foreign countries, respectively. Meanwhile, C and D essentially cover everything else. History of the ancient world is bundled with general history, and this is important because Classic history books, like Roman, Greek history books, contemporaneously written by Romans, Greeks, Syrians, etc., suffer the possibility of being shared in the same space as modern works. Rubicon, The Last Years of the Roman Empire, and Lives of the Later Caesars are both history books, yet they are leagues apart in terms of reliability and credibility. This is potentially harmful for a system designed for serendipitous browsing. The narrow and localized nature of LC classification allows librarians to create a system of call numbers that best suits their library. This strength is also the system's weakness. Compared to the verbose construction of Dewey's classification numbers, which can be unruly and lengthy if too many subclass numbers are added on or table numbers are added on, LC's main criticism is that the system focuses too heavily on existing collections rather than existing knowledge. For example, there's a growing movement in academia and museum curation which takes video games and wants them to be treated as an art form, and more than just the simple time sink that many people seem to believe. This idea is predominantly strengthened within the last 15 years, and an astonishing number of works have been published on the subject. For libraries collecting such types of books and journal entries, LCC may not be able to accommodate to this new subclass quickly enough. Opposed to DDC, whereas in this instance editors may have prepared for the emergence of this subclass and readily prepared so. However, this is an extreme example, but check out WorldCat and you'll see what I mean. Cutters and tables share similar uses. Both cutters and tables are designed to create added accuracy to the call number as well as design a unique call number for each item. Tables differ slightly from cutters in practice. Similar items organized in LCC have a larger chance to get the same initial alphanumerical call number than DDC, or I should just say the initial number than DDC. LCC uses call numbers to further differentiate between the works. However, as opposed to DDC tables, the initial letter of the cutter is based on the name of the author, a corporation, geographic location, or title. Tables are given as a result of the subject of the content. So compared between the two methods, Dewey tables classify around the ideas and the category of the item rather than just the item itself, as shown in LCC. Dewey and LC are the predominant classification systems in the United States, with Dewey finding its popularity in smaller public and school libraries, and LCC belonging to academic libraries predominantly. But by this point, both classification systems are, by the way that they're run, are tailored to their own strengths and weaknesses.
Hi there. My name is Alexandra DeLuna, and my portion of the presentation will involve exploring other classification systems beyond the Library of Congress classification and Dewey Decimal classification systems. While the Library of Congress and Dewey Decimal classification systems have become the most commonly used systems here in the United States, many libraries in our country and around the world continue to utilize other classification systems to meet their diverse needs. For the purposes of this assignment, I decided to focus on two popular systems that highlight the versatile natures of library classification schemes, and those are the National Library of Medicine classification, which I will refer to as NLM, and the Universal Decimal Classification, or UDC. The National Library of Medicine's classification system was developed to meet the needs of the National Library of Medicine, as well as other libraries specializing in the field of medicine and preclinical sciences. This system was designed with the goal of creating a classification scheme that would be compatible with the Library of Congress's system, while occupying the LCC's vacant schedules at subclasses QS through QZ and Class W. Now, QS through QZ are dedicated to preclinical sciences, such as human anatomy and physiology, and Class W is dedicated to medicine and other related subjects. It's important to note that the Library of Congress does maintain its own schedules for medicine-related and general reference materials, and those are located at the following classes and subclasses. You have Class R, which is medicine, subclass QM for human anatomy, QP for physiology, QR for microbiology, and in Class C you will find medical bibliographies included there. Materials that fall outside of the NLM's purview are usually classed using the Library of Congress's classification system. When it comes to notation, NLM follows the general pattern notation that's used in Library of Congress classification, with a few variations to meet its specific needs. NLM has developed class numbers that generally include 1 or 2 capital letters, followed by an Arabic number of up to 3 digits, with possible decimal extensions. This means that the NLM class numbers range from 1 to 999, in contrast to the LCC's number range of 1 to 9,999. Cutter numbers also play an important role in NLM classification practices, as they do in LCC, but instead of using the LCC's simpler cutter number table, however, NLM refers to the more complex Cutter-Sanborn 3-figure author table to determine its item numbers. And as you can see here, the resulting NLM call numbers do not include a period before the item number, which is also a departure from the Library of Congress's traditional call number format. You'll see a period or a decimal point located before the item number in the LCC call number shown here. Despite this, the variations that we see between the NLM and LCC patterns of notation, this really doesn't affect the overall compatibility of the two systems. Chan's textbook notes several advantages of the classification partnership between the National Library of Medicine and Library of Congress. One of the big things is that since both systems maintain their own schedules for medicine-related subjects, yet adhere to general LCC notation patterns, NLM's notational system is fully compatible with LCC. In other words, if you have a library that organizes their collection using the Library of Congress's system, they can still develop a collection that includes materials that might have been classed using NLM's notations without any issues. Another benefit of the compatibility between these two systems is that a number of medicine-related materials can be classified using both notations. What you'll find is that MARC records of medical literature prepared by NLM for the Library of Congress through their shared cataloging program contain both Class R and Class W numbers. And in case you've forgotten, Class R numbers are for Library of Congress and Class W is for NLM. For example, consider the second edition here of Mary Rudolph and Malcolm Levine's Pediatrics and Child Health, textbook published in 2006. This item can be shelved in a library using the NLM call number, which we see here, or the Library of Congress call number. Either one would work, depending on the library. The National Library of Medicine's classification system was designed to fulfill the needs of a special library while maintaining compatibility with an existing classification system, which is Library of Congress. In this next section, we are going to take a look at Universal Decimal Classification System, which is a system that was originally built on the foundations of a pre-existing classification system, but developed into its own independent scheme. So, the Universal Decimal Classification System, or UDC, is a bibliographic and library classification system that enjoys worldwide use in 130 countries and has been published in over 40 different languages. The European developers of UDC based their system on the Dewey Decimal Classification with the intention of creating a universal bibliography that would index all publications that were in existence, which was a very admirable but decidedly difficult goal. While The goal of a universal bibliography was eventually abandoned. UDC continued to develop into a freestanding library classification system, and in its current form, UDC is capable of indexing the continuously expanding universe of information resources, regardless of the medium of publication or the language used to convey that information. One of the strongest selling points of UDC is the universality and flexibility of its classification needs or methods. While UDC does adhere to the basic outline of the Dewey Decimal Classification System, UDC has made great efforts to move away from what might be called a decidedly Western-centric bias of Dewey Decimal. UDC's Class 2, for example, which covers religion and theology, has been revised to give equal treatment to each of the major world religions by arranging them in a historical order. This is a noticeable departure from Dewey Decimal's Class 200, which also covers religion, but shows a prominent bias towards Christian resources in divisions 220 through 280. All other religions are relegated to Division 290, which is aptly titled Other Religions. On the topic of notation, UDC has developed a notation system that is hierarchically and syntactically expressive. The longer the number, the deeper the hierarchy, and components in complex expressions are indicated by symbols and punctuation. UDC has adopted the Dewey Decimal System's base notation of Arabic numerals with a decimal following the third digit. However, UDC does not require three-digit integers as base numbers. Note the numerical difference between DDC's Class 500, which is science, and the UDC's Class 5, which is mathematics and natural sciences. UDC does not require the use of zeros as fillers within the notation. Instead, each digit is actually considered a decimal that represents increasing levels of division within the main class and results in a hierarchically expressive notation. The decimal point is inserted after the third digit, more so to break up the notation and allow for ease of reading the notation. And here we have an example of increasing notation divisions within UDC's Class 5, which is mathematics and natural sciences. You see we move from Class 5, which is mathematics and natural sciences, to physics, down to physical nature of matter, down to nuclear physics, and the like. Finally, the Universal Decimal Classification's notation method further departs from Dewey Decimal Classification in its use of facet indicators to build more complex notations. Now, facet indicators are connecting symbols that not only create links between different subjects within UDC, but also show the nature of the relationship between those subjects. A plus symbol, for example, is used to connect two closely related topics that may reside in two different classes, and the result is a syntactically expressive notation that conveys increasingly complex subjects through the connection of simpler topics. The adaptability and universal appeal of UDC guarantee that this classification scheme will probably remain popular within libraries around the world for the foreseeable future. Thanks.
How are classification systems, control vocabularies, semantic web, and simple knowledge organization systems, SKOS, related? Classification. The purpose of classification is to organize knowledge into successive stages of classes and subclasses. This makes it possible for information seekers to find and retrieve specific information with as little difficulty as possible. In information science, this is done through the use of classification systems, such as Dewey Decimal Classification and Library of Congress classification. with the advent of the computer age, has caused the need to develop other ways in which to classify new types of information for things like electronic databases, as well as documents and data created and housed on the World Wide Web. One such method is through the use of control vocabularies, which are lists of authorized subject terms that are used to gather like concepts together and used for information retrieval. They include items such as subject headings, such as the Library of Congress subject headings, thesauri, which is similar to subject headings but uses both singular and bound terms, such as type A personality, which can't be broken up, ontologies, which shows the relationship between concepts, entities, terms, and categories in a particular domain, but this does not use authorized terms. Taxonomies show a hierarchical classes and subclasses from broadest to narrowest terms. It's used on the World Wide Web through categorization tag coding, such as like you see on yahoo.com when you look at the categories of automobiles, careers, or parenting. Folksonomies, which is a public inputting of classification tagging and is not truly a control vocabulary because it lacks formal structure, such as having synonyms and antonyms, singular or plural terms, hierarchical relationship ordering, or even accurate spelling. Here are some examples of control vocabulary. This first example is a Library of Congress subject heading, in which case you could see it shows used for terms, broad terms, narrow terms. Our next example is of one of the thesaurus, which is from the ERIC Thesaurus, that's the Education Resources Information Center, which also uses used for terms, related terms, broad terms, and narrow terms. This example is of an ontology from WorldNet of the word hamburger, but not the food. You can see it shows broad terms or hypernyms, related terms, and derivation of terms. Our final example is one of a taxonomy of animals from the Encyclopedia Britannica, which shows a hierarchical classification of classes and subclasses from broadest terms to narrowest terms. Next we have the semantic web. The semantic web is not a separate web, but an extension of the current web, in which information is given well-defined meaning, better enabling computers and people to work in cooperation. It's accomplished through the use of agents, computer applications that parse through data and find relationships based on information entered by the user. A semantic web uses a resource description framework structure and a control vocabulary, and is usually coded through extensible markup language, XML. Let's take a look at how a semantic web search works. In this example, the software agent begins searching through different documents and libraries and finds a matching criteria, in this case, HAS Manual. So from the search of this document, it is revealed that this comes out with two more hits, one of a subject topic, and the other is based on a document. The topic yields no other hits, so we'll go back to the document, which turns out has an additional topic, but also has another hit for has author, for person. In this case, this person also reveals one final hit, lives at, and reveals a place, which was the ultimate criteria that the searcher was looking for. Simple Knowledge Organization System, SKOS. A more recent development in the semantic web structure is the Simple Knowledge Organization System, which provides a model for expressing the basic structure and content of concept schemes, such as control vocabularies, to be composed and published on the World Wide Web, linked with data on the web, and integrated into other concept schemes. It also uses an RDF framework and control vocabulary, and is also run through computerized agents. In fact, SKOS is itself an ontology, which was created through web ontology language, known more informally as OWL. Here is an example using SKOS coding and core vocabulary in a semantic web search. In this case, the term we're searching for is economic cooperation. Preferred label, that's the main search term, but it also comes up with an alternate label of economic cooperation with a hyphen. Then we have scope note, which it says includes cooperative measures in banking, trade, industry, etc. between and among countries. Next we move on to narrower terms, which has a preferred label of economic integration, European economic cooperation, European industrial cooperation, and industrial cooperation. A related term comes up with the preferred label of interdependence, and a broader search term comes up with the preferred label of economic policy. In conclusion, the relationship among classification systems, control vocabularies, semantic web, and SKOS is one of organization, structure, and information retrieval. They are all ways for users to search for and locate information, and they are useful for both physical materials and computer data. As classification methods such as semantic web are refined and newer systems developed, information science will continue to progress toward a more streamlined, data-integrated world. Thank you.